Hey, today I would like to do a presentation on tacheometric surveying. I would like to give more information on the determination of elevation and horizontal distance using the stereo method for a fixed hair. First of all, what is tacheometric surveying? What is tacheometry? Tacheometry or telemetry is a branch of angular surveying in which the horizontal or the vertical distance of points obtained by optical means is opposed to the ordinary slower process of measurements by tape or chain. This method is very rapid and convenient. It is best adapted in obstacles such as steep and broken ground, deep ravines, stretches of water, a swamp, and so on, which make chaining difficult or impossible. The primary object of tacheometry is the preparation of contoured maps or plans requiring both the horizontal as well as the vertical control. Also, on surveys of higher accuracy, it provides a check on distances measured with the tape. Tacheometry, it's obtained from the Greek word which means quick measure. It's a system of rapid surveying by which the positions, both horizontal and vertical, of points on the Earth's surface relative to one another are determined without using a chain or tape or a separate leveling instrument. Now, coming to the uses of tacheometry. Tacheometric methods of surveying are used with advantage over the direct methods of measurement of horizontal distances and difference in elevations. Some of the uses are preparation of topographic maps which require both elevations and horizontal distances. Survey work in difficult terrains where direct methods are inconvenient. Detail filling, reconnaissance surveys for highways, railways, etc. Checking of already measured distances, hydrographic surveys, and also for establishing secondary control. Now, the instruments which are used in tacheometric surveying is basically an ordinary transit theodolite fitted with a stereo diaphragm is generally used for tacheometric survey. The stereo diaphragm essentially consists of one stereo hair above and the other an equal distance below the horizontal crosshair. The stereo hairs being mounted in the ring and on the same vertical plane as the horizontal and the vertical crosshairs. Stereo is a tacheometric form of distance measure that relies on fixed angle intercept. Here we can see the different forms of stereo diaphragm commonly used. Basically, the telescope used in stereo surveying are of three kinds. The first one, which is a simple external focusing telescope. Second one, which is called as the external focusing enlantic telescope, which can be also called as the Poisson telescope. And the third one, that is the internal focusing telescope. A tacheometer must essentially incorporate the following features. The multiplying constant should have a nominal value of 100 and the error constraint in this value should not exceed 1 in 1000. Second one is that the axial horizontal line should be exactly midway between the other two lines. The telescope should be truly inelastic. The telescope should also be powerful, having a magnification of 20 to 30 diameters. The aperture of the objective should be 35 to 45 mm in diameter to have a sufficiently bright image. For small distances, say up to 100 meters, ordinary leveling shaft may be used. For greater distances, a stereo rod may be used. The same is usually of one piece, which is having at least of 3 to 5 meters of length. The same is graduated in 5 mm for smaller distances, while for longer distances, the rod may be graduated in 1 centimeter. This is the scale. Now, the different systems of tacheometric measurement. See, there are various systems of tacheometric survey which can be actually classified into three. First one, which is the stereo system. Second one is the tangential system. And the third one is the measurement by means of special instruments. The stereo system can be actually divided into two, which is the fixed hair method of stereo method. And the second one, that is a movable hair method, or it can also be called as a subtens method. I would be giving more information on the first one, that is a fixed hair method of stadia method. For all these systems, there's one principle that is really common, is to calculate the horizontal distance between 2 points A and B and the distances in elevation by observing the angle of the instrument at A subtended by a known short distance along a staff kept at B. Second one is the vertical angle to B from A. Now coming to the fixed hair method. In this method, basically the angle of the instrument at A is subtended by a known short distance along a staff kept at B is made with the help of a stadia diaphragm having stadia wires at fixed or constant distance apart. The readings are on the staff corresponding to all the 3 wires taken. The staff intercept, that is, the difference of the readings corresponding to the top and the bottom stadia wires, will therefore depend on the distance of the staff from the instrument. When the staff intercept is more than the length of the staff, only half intercept is read. For inclined sight, reading may be taken by keeping the staff either vertical or normal to the line of sight. This is the most common method in tacheometry, and it's called as the tacheometry, and the same stadia method generally bears reference to this method. Now coming to the principle of stadia method. The stadia method is based on the principle that the ratio of the perpendicular to the base is constant in similar isosceles triangles. The figure, you can see there are 2 rays OA and OB, which is equally inclined to the center ray, that is the OC. Here A2, B2, A1, B1 and AB be the staff intercepts. Thus evidently we can see that OC2 by A2, B2 will be equal to OC1 by A1, B1 and it will also be equal to OC by AB. This is also equal to a constant which can be called as K, and another way to calculate this constant K is by half cot beta by 2. You can see that beta is the angle as shown in the figure, and this constant K entirely depends upon the magnitude of angle B. In actual practice, observations may be made with either horizontal line of sight or with inclined line of sight. In the later case, the staff may be kept either vertically or normal to the line of sight. First, the distance elevation formula for the horizontal sides should be derived. Now about horizontal sides. Consider the figure in which O is the optical center of the objective of an external focusing telescope. Let A, C and B, as seen in the figure, these are the points cut by the 3 lines of the sight corresponding to the 3 wires. B, C and A equal to top, axial and bottom hairs of the diaphragm. AB is equal to I, which is the interval between the stadia hairs, that is the stadia interval. AB is equal to S, which is equal to the staff intercept. F, which is seen in the figure, is the focal length of the objective. So one more time I would like to say that F1 is the horizontal distance of the staff from the optical center of the object. F2, as you saw in the figure, is the horizontal distance of the crosswire from O, as seen in the figure. Then D is the distance of the vertical axis of the instrument from O. The capital D, as seen in the figure, is the horizontal distance of the star from the vertical axis of the instruments. Then M, the capital letter M, as you can see in the figure, is the center of the instrument corresponding to the vertical axis. Since the rays BOB and AOA pass through the optical center, they are straight so that AOB and small letter A, O, small letter B are similar. Hence, we can say that F1 by F2 is equal to S by I. I'll show the figure one more time. Since F1 and F2 are conjugate focal distances, we have we have formed the length formula, that is 1 by f. From the length formula, we get that 1 by f is equal to 1 by f2 plus 1 by f1. We are multiplying f1 throughout, so we get f1 is equal to f1 by f2 into f plus f, as seen in the figure. Now, if you substitute the values of f1 by f2 is equal to s by I in the above, we get f1 is equal to s by I into f, the whole, plus f. Now, horizontal distance between the axis and the staff is d, the capital letter D, which is equal to f1 plus d. We can elaborate and find the distance with the formula as shown, which is equal to capital letter D is equal to f by I, the whole into s plus f plus d, which is equal to k, which is the constant, into s plus capital letter C. Now coming to the distance and elevation formula for staff vertical, which is the inclined side. Here P is equal to the instrument station, Q is the staff station, capital M is equal to the position of instrument's axis, capital O equal to optical in center of the objective, etc. Coming to the elevation of the staff station for angle of elevation. If the line of sight has an angle of elevation theta, we can say that elevation of staff station is equal to elevation of instrument station plus h plus v minus r. Elevation of the staff station for the angle of depression will be equal to elevation of q, which is equal to elevation of p plus h minus v minus r. This is the figure. Here the distance and elevation formula for staff normal, which is for the inclined side. At the angle of elevation theta, we can see that AB is equal to S, which is equal to staff intercept, CQ is equal to R, which is equal to axial hair reading. We see that MC is equal to capital letter A, which is equal to capital letter K into S plus C. This is a formula to find the horizontal distance between P and Q. Thank you. I hope that this video was really helpful for you, especially to know the determination of the elevation and the horizontal distance using stereo method for a fixed hair. Thank you.